Can you draw the border plot for, let's say, draw the border plot for So draw the border plot for the second one also. Second one, first you need to transfer into standard form. So first one, what are the, let's say, corner frequencies? 1, 0, 0, 1, 1, 2, 6. These having plus 1 slope. This has, sorry, 1 by 2, 1 by 6. This has minus 1 slope. So S has minus 2 here, plus 2, plus 2, plus 2, plus 2, infinity. Yeah, 1 by 6 is 3 times, correct. One by 6. Six s plus 1, 0, minus 3, minus 3, minus 3. 2s plus 1, 0, 0, minus 1. So 0, 0, 0, plus 2. So what is the overall slopes? Plus 2, minus 1, minus 2, 0. So this will be plus 2, minus 1, minus 2, 0. So what is the starting value is 1. So e power minus something has no effect on the transfer function. E power minus s has no effect on the transfer function. Is the slopes and everything right or something wrong? So next one is e power minus s. This is not 8, e power minus s. Transportation. So next one is s by so what happens is so what are the corner frequency? 0, plus 1, plus 1, minus 1, minus 3, plus 1, minus 1, minus 3. Kp in the starting problem is 4 by 25. Next, what we discuss is phase angle Bode plot. Let's start a simple one. 1 by tau s plus 1. What is the phase angle? Tan inverse of minus omega tau. So what is the limits? When omega is equal to 0, what is the phase angle? Tan inverse of 0 is 0. When omega is infinity, what is the phase angle is minus pi by 2. So what is the limits of phase angle is 0 to minus pi by 2. Now how do you draw the phase angle Bode plot is phi versus omega tau phi. What is the limits is maximum is minus pi by 2 0. This is 0 to minus infinity or infinity. So when omega tau is equal to 1, that is where the phase angle is, let's say minus pi by 4. This is what. So why it is 0 to minus pi by 2? Because you have found out here the values, no? When it is 0, it is 0. When it is infinity, it is minus pi by 2. So the maximum limits is 0 to minus pi by 2. So it cannot go beyond that. So here directly the plot of phi versus omega tau. So the direct plot, here there is no log-log plot. Clear? Phi versus omega tau. Now we will translate this curve into, let's say phi versus omega, which is actually something like this. This is the Bode plot, sorry, not phi versus omega tau, phi versus omega. So this is when omega becomes 1 by tau, you have minus pi by 4. This is 0, minus pi by 2. So this is infinite. Zero. Clear? So here, whether for Kp by tau s plus 1 also, the phase angle will be same. Phase angle is tan inverse of minus omega tau. So here, what is important is, here the plots are not important. Plots doesn't change. Basically, the limits 0 to minus pi by 2. Suppose if I have a second order system, 1 by tau 1s plus 1 into tau 2s plus 1. Then what is the first phase angle? Is sum of initial both the phase angles. Then what it becomes, the limits 0 to minus pi. 0 to minus pi. Okay, so this is what is Bode plots. So what we have done is amplitude ratio, Bode plots, phase angle, Bode plot. Amplitude ratio Bode plots, slopes are important, gate point of view. Phase angle Bode plots, ranges are important. Ranges are important. So in the ranges, for proportional controller and PI controller, PD controller, so what are the ranges? For pre-controller, what is the phase angle? 0, there is no range. For PI controller, what is the phase angle? Tan inverse of minus 1 by tau by omega. So what is the range? When omega is 0, it is minus pi by 2. Minus pi by 2. When omega is equal to infinity, it becomes 0. So minus pi. So the range is minus pi to pi. For proposed derivative controller, omega tau d. So when omega is 0, 0. Omega is infinity, pi by 2. So this is how you find the ranges. See, there is no log AR here. It is directly plotting. So that is why it is actual graph. So it is not important gate point of view. Ranges are important gate point of view. So Bode stability criteria. So next one is Bode stability criteria. So what is Bode stability criteria? Just write this statement. A control system is unstable if an open loop frequency response exhibits an amplitude ratio exceeding unity exceeding unity at a frequency for which the phase lag is 180. This frequency is called as crossover frequency. So this is the Bode stability criteria. So a control system is unstable if a frequency response exhibits an amplitude ratio exceeding unity at a frequency for which the phase lag is 180. So this frequency is called as crossover frequency. So have we, here you don't know multiple terms. Let's target understanding multiple terms. First one, open loop frequency. So what is meant by open loop frequency? Open loop frequency. Suppose let's check whether the system is stable or not. Let's say 2, 5, or let's take 10. 1 by s plus 1 plus. So whether this system is stable or not. So how do you find whether this system is stable or not? So using Routh criterion. So one is Routh criterion. In the Routh criterion, what do you do? So in the Routh criterion table, what do you do is you find the transfer function, equate the denominator to 0. So that is called as characteristic equation. So from the characteristic equation, so you find the Routh criterion table and then you will do the analysis. But here what do you do is you find an equivalent open loop response. So what is open loop is, this is the closed loop. But the analysis that you will do is on the open loop. So what is meant by open loop is, if there is no feedback, no feedback is called as open loop. That doesn't mean that in the plant it is open loop. Plant it is closed loop only. But for the analysis, we will do it as a open loop. So 10. Then what is the system's 10? 1 by s plus 1. So then what is open loop transfer function? What is open loop transfer function? Which is 10 by s plus 1. What is open loop transfer function is 10 by s plus 1. Clear? So have you understood what is open loop? That doesn't mean that in the plant also there is Open loop. Plant, it is reality is closed loop only. But this is a open loop. So what is open loop transfer function? 10 by s plus 1. Now what you should do is equate this is the open loop transfer function. Does everybody understood what is meant by open loop? This is called as open loop transfer function 10 by s plus 1. Okay, then what you should do is now the open loop transfer function is 10 by s plus 1. So equate the phase angle of 10 by s plus 1 to minus 180. So what is open loop is when there is no feedback is called as the open loop. So when the plant, that doesn't mean that in the plant also it is open loop, but it is in the plant it is closed loop only. But we will do analysis on the open loop. So equate the phase angle of the open loop to minus 180. Then what it becomes? Phase angle of minus 180, phase angle of 10 plus phase angle of 1 by s plus 1, so which is equal to minus 180. Phase angle of 10 is 0. Phase angle of this one is tan inverse of minus omega tau, which is equal to minus 180. Let's take, I'll change the transfer function. Just take this as s power 4, s power 4, s plus 1 whole power 4, so that the numbers will become simple. So what you get is power 4, so into 4 into, so what will become is tan inverse of minus omega tau equal to minus pi by 4. So what is omega tau is equal to 1. So what is tau? Tau is 1, no? So then what is omega is 1. So this omega equal to 1 is called as, this omega equal to 1. This omega equal to 1 is called as crossover frequency. This omega equal to 1 is called as crossover frequency. So let's show the previous slide also. Omega equal to 1 is called as crossover frequency. Now you find amplitude ratio of 10 by s plus 1 whole power 4. So now calculate what is it is amplitude ratio of 10 into amplitude ratio of n whole power 4. Amplitude ratio of this is 10, 1 by root of 1 plus 1 whole power 4. 10 by 4. So which is, this is greater than 1, no? So the system is unstable. The system is unstable. So the frequency at which the phase angle is minus 180, at that frequency, the amplitude ratio is greater than 1. So that is where the system is unstable. Same problem. See, you calculated the frequency. That frequency, how did you calculate this frequency? When the phase angle is equal to minus 180. When the phase angle is equal to minus 180, you have calculated the frequency. So that frequency is equal to 1. So at that frequency, you calculated the amplitude ratio. See, it is greater than 1. So the system is unstable. Now, repeat this problem. Repeat this problem 2. Rest ever remains same. So can you check whether this system is stable or not? So how do you do this analysis? First find the phase angle. First equate the phase angle to minus 180. Find the frequency. At that frequency, find the amplitude ratio. Just stable. So what is the omega that you are getting is same 1. But now what is the amplitude ratio that you are getting is 1 by 2, which is less than 1. That is why the system is stable. Same question, you just replace this with 4. Then what is the answer? Now, in this question, what you are getting, second question, you will get W at equal to 1, but your amplitude ratio is exactly equal to 1. That is why you will call it as verge of stability. Clear? I think I will take class up to 5 only today, so I have some work. So I have one or two problems more on this one, so I will continue tomorrow. So is everybody clear with the topic? How do you define Bode stability criteria is? First you define the open loop. What is meant by open loop is when all the elements are connected in series, it is open loop. Clear? Second one is, so equate the phase angle to minus 180. Yeah, we will solve the gate question. How they will ask is stable or not unstable. They will put this value as, let's say, simple Kc. What is the value of Kc at which the system is stable? So that is how the question is. Yeah, gate questions we will solve.